Hello students, welcome to my channel. This is your Jaspreet teacher. In today's section, we are going to solve exercise 6.2 question number 5 from chapter triangle 10th standard. Okay, so we are going to do exercise 6.2 question number 5. Already we discussed question number 1, 2, 3, 4 in my previous lecture. Before doing this, you can go through my other videos, my previous lecture in which we discussed question number 3, 4. And in this question, we are going to use basic proportionality theorem and converse of basic proportionality theorem. That is Thales theorem and converse of Thales theorem. We are going to use this result of these theorems. So before doing any question, you should know all the theorems. You should know where you have to apply which result of which theorem. Okay. So if you know the statement of any theorem, then you can apply in each question. You can judge where you can apply the result of which theorem. Like I'm just giving you just little information like if we have two sides are parallel, then which theorems you can apply. If two lines are parallel, we can apply Thales theorem. The other two sides ratio will be same. Okay. Then if a ratio will be same, the sides will be parallel. This is the converse of the Thales theorem, which we are going to use here. Okay. So come to your solution. We are given with triangle PQR. So in this question, what is given? Just give one look. In triangle PQR, you are given with DE. Your DE side is parallel to OQ. This DE is parallel to OQ. Okay, this DE is parallel to OQ. And DF, this DF is parallel to OR. This is given. Okay, and you have to prove this EF is parallel to, you have to prove EF is parallel to QR. Got it? These two sides you have to prove parallel. EF is parallel to QR. Got it? So now, first of all, we'll take one triangle. In triangle POQ. POQ. In this triangle, sides ED is parallel to OQ. This is your given. So we'll always use whatever is given. We'll start our question from that. ED is parallel to OQ. So if two sides are parallel, which theorem we can apply? We already discussed in so many questions. In my previous lecture, I already discussed. If two lines are parallel and that two sides, that line which is parallel to other side cuts at the other two sides at two distinct points, that is point E and D, then the other two sides are divided in the same ratio. Which two sides? The side PQ and side OP. It divides in the same ratio. That is, I am taking ED is parallel to OQ. So side PE upon EQ will be equal to side PD. Okay. Side PD upon, I am taking PE upon EQ, side PD upon DO. Right? This is my first result. Why we are using this? By which theorem? By, you can write the reason here, basic proportionality theorem, BPT, or Thales theorem. This is your first result. Now come to the second triangle, that is triangle POR. First I took POQ. Now I am taking POR. This one I am taking POR. In triangle POR, again I have side DE, side DF is parallel to, side DF is parallel to OR. Okay, this side DF is parallel to OR. Again, sides are parallel, then the other two sides will be in the same ratio according to what? Thales theorem. Then PF upon FR, PF upon FR will be equal to PD upon DO. PD upon DO. This is your second result. By, again I am using basic proportionality theorem. the result of basic proportionality theorem. Why we are using here basic proportionality theorem? Because two sides are parallel. If sides are parallel, the other two sides ratio will be same. This is your basic proportionality theorem. Now from equation 1 and equation 2, what we have, we'll see what we'll get. This, my right side of this equation, PD upon DO, will be equal to the right side of my second equation, PD upon DO. So my two right sides are same for both equations, then left side will be equal. This PE upon EQ will be equal to, so we have PE upon EQ will be equal to PF upon FR. Come to your diagram. PE upon EQ, we got this one, PE upon EQ will be equal to PF upon FR. So now come to this triangle, in triangle PQR. Now we are taking full triangle, in triangle PQR. Okay, what we got now, we are using this result here, this one, PE in triangle PQR, PE upon EQ is equals to PF upon FR. We can say like that, we have PE upon EQ is equals to PF upon FR. Why? Proved above. You can give the reason why you are writing this here. Proved above by result of basic proportionality theorem. Now in triangle PQR, my ratio is same, PE upon EQ, PF upon FR. If my ratio of two sides are equal, then what? Which theorem we can use here? If ratio of the two sides will be equal, then that sides will be parallel according to converse of Thales theorem. So my which side? EF will be parallel to QR. So this implies EF is parallel to QR. That you have to prove. Okay. So you can give the reason here. If ratio of two sides are equal, then that side is parallel to the third side. That side is parallel to third side. Okay, by converse of basic proportionality theorem. Okay, so what my converse of basic proportionality theorem states, if the ratio of two sides are equal, that two sides ratio if equal, then that line joining that midpoint of that two sides are parallel to the third side. Got it? This is your converse of Thales theorem. So in case you are not getting this converse of BPT theorem, you don't know this theorem, and basic proportionality theorem and its converse you don't understand, so please go through my link. I am giving link in this session. In description box I am giving link of basic proportionality theorem and the converse of basic proportionality theorem. You can watch that first before doing this example, this question. Then easily you will get the answer of any question. Okay, like 6 question also is same, just like this question. I have PQR in that question also. We can discuss in a next lecture, or first you also do at home. Try to solve question number 6 by the help of question number 5, which we already discussed. In case you are feeling any difficulty, any problem, please share with me in comment box. I will solve your problem. You are totally free to share with me. Okay, I hope you understood today's lecture. Please share, subscribe and like, and press bell icon button. Thank you so much.